All right, we've gotten to the end of our unit now, and I want to talk about the study guide. You should have did the study guide yesterday by yourself. I want you to watch this video and compare what your answers are to the study guide. Make sure if you have any questions on this stuff, make sure you get a hold of me so we can meet during STEP and talk about the correct answers for these. So the first thing it says, explain how each pair, explain how the meanings of the terms differ. So when I take a look at a solid and a liquid, we know that a liquid has more energy. Okay. We also know that it is free flowing. And then a solid has a defined shape. Okay. And it's low energy. We've talked about this a lot. Okay. We've talked about this a lot. Okay. And then the second one is Charles' law and Boyle's law. Okay. Charles' law and Boyle's law. Charles' law, Boyle's law. Charles' law is on as temperature goes up, pressure goes up. When temp goes down, pressure goes down. Boyle's law, remember we said they're inversely proportionate. So when our pressure goes up, our volume goes down. This would also be for volume up here for Charles' law. And when our pressure goes down, our volume goes up. Okay, our volume goes up. All right, so that is the difference between Charles' law and Boyle's law. What is the difference between evaporation and boiling? Okay, the difference between evaporation and boiling. Well, evaporation is a change in state. Okay, evaporation is a change in state when we're going from a liquid to a gas. Or boiling is when pressure is more about pressure. When we can make things boil without even heating them. As long as the inside pressure matches the outside pressure, we get boiling from that. Condensation and sublimation. Condensation is from when a gas goes to a liquid, and sublimation, remember we did this with our dry ice, goes from a solid to straight to a gas. Okay. Look over your answers there. See if you got them right. Okay, see if you got them right. I know for your test for sure, you're going to want to know this. You're going to want to know this. And you're going to want to know this, change of state. This evaporation and boiling part, I don't think that's on the test. Okay, let's take a look at question number 5. It says, which of the following statements best describes the particles of a liquid? Particles are far apart and moving fast. Well, that would be a gas. The particles are close together but move past each other. Yeah, that's a liquid. The particles are far apart and moving slowly. No, that's not true. That would be the particles are close. This is a solid, so our answer would be B. Our answer would be B. Take a look at number 6 now. It says, which of the following statements describe what happens as the temperature of a gas in the balloon increases? So when our temp goes up, now think about like your tires in your car, or in a balloon, or when we heat it, when we the speed of the particles, they would not decrease. That's if we cool it. The volume of the gas increases and the speed, yeah, that's it right there. And the speed of the particles increases. Volume, no, that wouldn't decrease. And our pressure wouldn't decrease. So our answer is B. Number 7, boiling points and freezing points are examples of what? Not chemical properties, because chemical properties represent a change in matter. It's not an energy. It's not anything about matter. They're physical properties. Remember, each thing, water has different melting and boiling points and freezing points than like gasoline. All right. Number 8, dew collected on a spider web in the early morning is an example of, and remember I talked about how when I would go golfing in the morning, we have all that water on the ground and it didn't rain and the sprinklers didn't go because of that condensation from the water vapor inside settling on that cool grass. Number 9, during which change of state do atoms or molecules become more ordered? Now think about our particle models. Here's a gas. They're all over. Right? That's a gas. Here's a liquid. They're kind of close to each other and they're free flowing. Okay. And then here's our solid. Okay. So they're getting tighter together. All right. So that means we're going backwards. We're going from a gas to a liquid to a solid. The cooler we get, the more ordered our particles become. So if we take a look at these, boiling, are we adding energy or taking it away? Well, we're adding energy, so that wouldn't be it. Melting, are we adding energy or taking away? Well, then we're adding for this. Sublimation, we're adding. We're going from a solid to a gas. Condensation, the only thing we're doing there is we're taking away energy. We go from a gas to a liquid. So we go all over to bringing them in closer together. So our answer would be, now if this said freezing, that would also be an example of where our molecules become more ordered. Which of the following states is an exothermic? Okay, exo means released. Okay, releasing heat. Okay, so when we go, we're adding heat. We're adding. Okay, we're adding. So freezing? No, that wouldn't be right. Melting? Yeah, melting would be right. Okay, melting. All right. Let's move on. Number 11. What happens to the volume of a gas inside a temperature? Hold on, let me try to get this. What happens to the volume of a gas inside a cylinder if the temperature does not change, but the pressure is reduced? Okay, that means we're releasing pressure, so we're getting more volume. Okay, there's not enough information. The volume of the gas is decreased. The volume of the gas stays the same. The volume is increased. So A, we have less pressure. Okay, so that means it gets bigger. The atoms and molecules in matter are attracted to each other, are constantly moving, are moving faster at higher temperatures, or D. Okay, all of the above. They do all of those things. We do all of those things. Okay. Number 13. Explain why liquid water takes the shape of its container, but ice does not. Well, let's take a look at our particle models. So here is a solid. Solid are connected, right? So they can't move. Whereas a liquid, they are free flowing. So we'd say particles in a liquid are free flowing and can move past each other. All right, let's take a look at now number 15. Number 15 is kind of a tricky question. As water can be split into two new substances, hydrogen and oxygen. Is this a change of state? Explain your answer. Well, if we take a look at H2O, and I've talked about this a lot, we have two hydrogens and two oxygens. We pass electrical current through H2O. It has enough energy, you'll break those bonds apart. But remember, if that were to happen, we won't have hydrogen and oxygen combined. We'll have pure hydrogen and pure oxygen. Now, they don't have the same characteristics as water. So this is not going to be a change of state. This is going to be a chemical change. Okay, this is going to be a chemical change because we have new properties. And we have brand new properties for that. So we won't have anything. I mean, they'd be a different state. Obviously, yeah, they'd be in a different state, but a change of state, that's a physical change. When we get brand new characteristics like this is going to be a chemical property with new properties. So that's not a change. That's not a change of state. That is a chemical change. Let's take a look at 16. After taking a shower, you notice small droplets of water cover the mirror. Explain how this happens. Be sure to describe where the water comes from and what kind of change it goes through. Well, water droplets come from our water vapor. Okay, and it condenses on the cool surface of the mirror. Okay, now remember when it hits the mirror, I'm going to draw a little picture of it over here. When it hits the mirror, it takes away energy. Takes away energy, and that's why we get these drops on that window. It takes away energy. All right, number 17. To protect their crops during freezing temperatures, orange growers spray water onto the trees and allow it to freeze. In terms of energy loss and energy gain, explain why this practice protects the oranges from the damage. Okay, why do you think that? Well, I mean, why? This is an interesting question. Why would I want to freeze it? Okay, because remember when we talked about water? Water freezes at what? 32 degrees Fahrenheit or 0 degrees Celsius. So could it get any colder than this? No. Okay, it can't get any colder than 32 degrees Fahrenheit. That's not possible. All right, when we take a look at this chart, if you remember when we talked about, we had this would be a solid, this is a liquid, and this is a gas. Okay, make sure this is on your test. And that is on your test. You want to make sure that this right here, you know this. Okay, you need to know this. This right here, from a solid to a liquid, that is called its melting point. Okay, and what do you think this is right here? Evaporation. Okay, this is melting or freezing. That's evaporation or condensation. Okay, so because if we go this way, we're condensing it. Okay, all right. Make sure you know this part right here, that this is a solid, this is a liquid, and this is a gas. And we look at 18, it says, what is the boiling point of a substance? What is its melting point? Well, the boiling point is the same thing as evaporation. Okay, its boiling point is when a liquid turns to a gas. That's boiling point. That's when it turns to evaporation. And its melting point is when a solid turns into a liquid. Okay, where a solid turns into a liquid. All right, 2 more questions here. At what state? Now we always think that this is water, but it doesn't have to be water. It can be anything. It says at what state is present at 30 degrees? So I would say 30 degrees right here. So that would be what state would we be finding at 30 degrees? Well, that would be a liquid. Okay. How will the substance change if energy is added to the liquid at 20 degrees? So at 20 degrees, we're at a solid, right? If I add more energy to it, what happens? It's its melting point. The solid is going to the liquid. All right. There's your study guide. Look that over. That's a lot of the stuff that's on the study guide is going to be on your test. So make sure you look that over. Hopefully, when you did the study guide, you were as descriptive as I was. Make sure you add any notes to your study guide or watch this video to know what you need to study for the test. All right, for what you need to study for the test tomorrow. All right, good luck. Let me know if you have any questions about any of the concepts that we talked about. Okay, make sure you let me know so I can meet with you.